Hi there, this is Jake and Mash Engineering Lessons, and this is Unit 2.1, Lesson 13, on how to solve Activity 2.1.5. Now, I'm not completely sure if this will be the exact same thing as what you have to do. I'm not sure, though. So I'm sorry if this is not even what your version is, because it may have changed. But the first thing says, write down the equation for calculating the turning force or moment and include the units. So, this is our equation for finding moments. And then the force is going to be in newtons not meters, pounds, and the distance is going to be in feet or meters. And the ones that have to go together for the unit pairs are these two. That answers the next question. It has to either be newtons meters or pounds feet. Now we have a few problems about seesaws. So let me draw the seesaw. So here we have the seesaw with fulcrum here. Then we have two kind of, I don't even really know what that's supposed to be. Just weights, I guess. And then we also have forces that are this way and this way. So the first one has a 2 newtons force and a 20 newtons force. Then it has 4 meters distance here and then 40 meters distance here. Is it balanced or not? How can we tell? Well, we need to multiply. We have to see the moment on each side of the seesaw by multiplying the distance times force. This distance times this force is going to be 80 newtons meters. And it's the same on this side. So, yes, it's balanced. For this first seesaw, it's balanced. Now, let's erase this, because now we have a different numbers. Now it says we have a 2-pound force on the left, also a 2-pound force on the right. We have 4 feet distance on the left and 3 feet distance on the right. Is it balanced? So we multiply those two and we get 8 pounds feet. And then on this side we get 6 pounds feet. So no, numbers are different, so it's unbalanced. But it also says if it is unbalanced, you need to say what side will go up and down. The heavier side will go down and the lighter side will go up. So that's what it is for that one. Now we have even different numbers for the third seesaw. Okay. Now, for the next one, we have 2 newtons force on the left, 0.5 newtons on the right. We have 0.75 meters on the left and 4 meters on the right. Is it balanced? No, it's not balanced, because we get 0.5 newtons meters on the left and we get 2 newtons meters on the right. The heavier side will go down and the lighter side will go up. That's the answer for that one. Now we have the fourth one. and it's starting to get completely erased. Try to draw that back. Now, for this one, we have 0.8 pounds on the left and 0.2 pounds on the right. We have 4.5 inches on the left for the distance and 7.3 on the right. Once again, this is unbalanced, but this time we have inches, so we have to convert to feet. We can do that by dividing by 12. And when we do, we get... Oh, well, actually, what we can do is, for this one, is do this. Type it in the calculator like that, and then we get 0.3 pounds feet. For the left side, and then for the right side, we get, this is what you can type in the calculator, and then we get 0.12 pounds feet. Once again, this is unbalanced, and the heavier side will go down, and the lighter side will go up. We have a fifth seesaw, though, that I'll just completely redraw. And it says, create your own seesaw and decide if it's balanced and or which side will go up and down. You can do whatever you want. I suggest you use your own example, but you're free to use this one. So I just made one with a 5 Newton force on the left, a 7 Newton force on the right, 7 meters distance on the left, and 5 meters distance on the right. And yes, that would make it balanced, because both sides have 35 newtons meters, because 7 times 5 is 35. There you go. Now we have just, let's see, 6 more problems. Now we have to do 2 crane problems. I can't really draw the cranes that good, but I'll try. Well, actually, it lists the things also. So it says there is for one part of the crane, there is a force of 800 newtons and a distance of 5 meters. You multiply those two together and you get 4,000 newton meters for the moment. That's simple. For the right side, well, there's 2 more moments. So there's one with a force of 600 newtons and a distance of 12 meters. For the moment for that one, you get 7,200 newtons meters. There's one more moment for that first crane, and there's a force of 800 meters, or newtons, sorry, and a distance of 5 feet. This time, or sorry, it's not newtons for that, it's pounds. And then you get 4,000 pounds feet. So that's the 3 moments for the first crane. Now let's do the second. The second crane has only 1 moment to solve for, at least that. And it says there is a force or a mass of 20 pounds and then a distance of 25 feet. You multiply those two together and then you get 5,000 pounds feet. That is the crane problems. Now we have the ones, the 4 problems that say moment problems. And this actually might be the PLTW thing that you have to do. So this is like the problems that we did for the slideshow I did. So let's try to draw this. It's a longer wrench. We have a bolt here. This distance is 4 inches. This is the D of 18 inches. And then we have a force of 80 pounds. So we use moments equals force times distance. And so the force is 80 pounds. So we found out that. And then the distance is well, it's in inches, so you have to convert to feet. So you can do that by divide by 12. 18 divided by 12 is 1.5 feet. Then we can multiply 80 pounds times 1.5 feet. Negative, though, because since the force is going this way, it's going to go clockwise. And clockwise equals negative. That's why. And so we end up getting 36.16 feet. Pounds feet. Sorry. The 16... Or, what's wrong with me? I'm sorry, that's not a 16. I couldn't even read my own handwriting. It's 36 pounds feet. For some reason, I thought that the pounds was at 16. Sorry. That is the first wrench. Second wrench now is a Z wrench. Oh, I'm sorry. I said that was a longer wrench. That first one was actually an L wrench. Sorry. Now, if some of this doesn't make sense to you, I suggest you watch the lesson 11, or 12, sorry, lesson 12. So we have a down force of 16 pounds. We have this distance that pretty much won't be used of 6 inches. And then we have 0.5 feet. Oh, sorry, that went too far. That was supposed to go that far. And then the other part is 18 inches. We are using this equation again. The force is 20 pounds, 16 pounds, sorry. Distance is, we need to add these because it needs to be from the force to the bolt. So this is in inches, it needs to be in feet. So 18 divided by 12, remember that's 1.5 because we already said that. Times, or not times, sorry. Plus, dang it. That is 2 feet. There we go. Now we can multiply 16 times 2, negative, because the force is down, so it's going to go this way, which is clockwise, and we said clockwise is negative. So that's negative 32 pounds feet. There we go. That is problem number 2. Well, wrench problem number 2 at least. Now we have a wheel and axle problem. Now I cannot make this look exactly right, but let's try. I'll try. Okay. There we go. Okay, that's the best I can do. We have a radius of 40 centimeters. Oh, can't write that high for some reason. And then we have a down force of 340 pounds. Luckily, we didn't have to do one of those ones where we have to do that cosine or sine for this one. That's simple, because all we have to do, well, we probably should make our answer in Newton's pound or Newton's meters, because this is in centimeters, and we need to, the two things I underlined, we need to convert centimeters to meters and pounds to newtons. So we're using, nothing's changed, the same equation. Force is 340 pounds, but since that needs to be in newtons, we multiply by 4.45 to get 1,513 newtons. And then distance is 40 centimeters, but that needs to be in meters, so we divide by 100 to get 0.4 meters. You multiply those two to get, well, for one thing, it needs to be positive, because this downforce means that it's going to be going this way, which is counterclockwise, which means it's going to be positive. And we get 605.2 newtons meters positive. And that's the wheel and axle problem. We have one more problem left in this video. Thank you for bearing with me. I have no clue how long this has been on, but I am assuming that it's been on a while, so thanks for watching so far. We have to now, what is it? We have two levers, and we're trying to find the distance. Well, this one we don't have to use this equation that we used in the last video, because luckily they gave us the moment, so we don't have to do that. So there's part A and B. So A, we have one here that looks like this, and we know that the moment is 2 newtons meters, and the down force is 0.5 newtons, and we need to find the distance. So what's the distance? How can we do this? We still can use, oh, that's not right. We can still use this equation. So m we substitute with 2, force we substitute with 0.5, distance we just do d. We can divide by 0.5, and then we get d is 4 meters. For B, we have still a moment of 2 newtons meters. We have a force up this time of 8 newtons. We can substitute using this equation, 8 for the F, D for D because we don't know about it, and then 2 for the moment. Then we divide by 8, and we get 0.25 meters for the distance. And that is activity 2.1.5. Thank you for watching, and I will see you on the next video about trusses. Thank you for watching.